We got 10.2, part 2 homework. Analytically show the equations below represent trig identity statements. I'm going to start with the left side because it's more complicated. I'm going to reciprocate this. Wow, this was much faster than I thought. Reciprocal of secant is cosine. That's what the right side was all along. That was scarily quick. Number 2, I feel like the right side's more complicated because there's subtraction and there's fractions. I'm going to change secant to 1 over cosine of theta. Going to get common denominators on the left, or on the right, I should say. It's going to give me 1 minus cosine squared of theta over cosine of theta. I think we know at this point that 1 minus cosine squared of theta is sine squared of theta. That's what the left side was from the beginning. So we have proven it. Number 3, left side feels more complicated to me, so I'm going to work with that. I'm going to change cotangent to 1 over tangent. Here's the time where I'm not going to change everything to terms of sine and cosine, just because I'm feeling froggy. Get common denominator, so I'm going to multiply the fraction on the right by tangent of theta over tangent of theta. It's going to give me 1 plus tangent squared of theta over tangent of theta. Now 1 plus tangent squared of theta, that's Pythagorean identity, that's equal to secant squared of theta. Now I'm running out of ideas. So I am going to change things in terms of sine and cosine now. But before I do that, I don't want this to be a fraction, so I'm going to reciprocate tangent, which is going to make that cotangent. So reciprocating it, I took it from the bottom and put it to the top. It doesn't make sense, come see me and I'll explain a longer version of that. Secant, in terms of sine and cosine, is 1 over cosine squared. Cotangent, in terms of sine and cosine, is cosine over sine. Now I can cancel a cosine from the top and the bottom. That gives me 1 over cosine of theta times sine of theta. If I reciprocate both of those, I'm going to get secant of theta times cosecant of theta, which is what the right side was from the beginning. Cool. Number 4. Right side, more complicated. I'm going to GCF out of the right, cosine of theta. It's going to leave me with cosine squared of theta plus sine squared of theta. Well, that's equal to 1, yo. Cosine times 1 is cosine of theta. Left side is not that, so I need to work with it as well. I'm going to change cotangent in terms of sine and cosine. Multiplying and dividing by sine, so I'm left with cosine of theta, which is what the right side is. Number 5, left side's more complicated. I like to start with the more complicated side. I'm going to change everything in terms of sine and cosine. So I got 1 over sine of theta plus cosine of theta over sine of theta. That's cool that there's common denominators there. Going to change tangent to sine over cosine. And I want sine to have a common denominator, so I'm going to multiply it by cosine over cosine. Now I'm going to simplify and make each of these numerators and denominators one fraction. That's going to be 1 plus cosine of theta over sine of theta over sine of theta plus sine of theta times cosine of theta divided by cosine of theta. Now that the numerator and denominator, one fraction, we can try to make this not complex. To do that, I'm going to multiply the top and bottom by sine of theta. That gets rid of that denominator. Going to multiply the top and bottom by cosine of theta. That gets rid of that cosine. So now we're going to have cosine of theta times 1 plus cosine of theta. And on the bottom, we're going to have sine of theta times sine of theta plus sine of theta cosine of theta. Everything else has been canceled out. I'm going to GCF a sine out of the bottom. I think you'll appreciate what happens. That's going to be sine squared then. And my parentheses is 1 plus cosine of theta. Well, those 1 plus cosines of theta cancels because we're multiplying the same thing on the top and bottom. So now we have cosine of theta divided by sine squared of theta. At this point, I don't know what to do. The right side, I'm just going to write it down so I have to keep looking up there, is cotangent of theta times cosecant of theta. So here's what I'm going to do. I'm going to separate the sine, so I got cosine of theta over sine times 1 over sine of theta. And that's because I recognize this is the reciprocal of sine, and because this is the same thing as cotangent. And that gets me to where I want to go. That is equal to the right side. Once the left and right sides are identical, you're finished. See, we got one more to do, number 6. Let's see. I think, is there no 7? There's no 7. Number 6. Which side's more complicated? I'm not sure. I'm going to start with the left and see what happens. Cotangent, its reciprocal, is tangent. So I can move that to the bottom. Then I can cancel a tangent from the top and bottom, and now I have tangent squared of theta is what that's equal to. So somehow the right side becomes that as well, and I guess that's pretty easy to see. This is sine of theta over cosine of theta times tangent. It's a different way to write it, which makes this tangent of theta times tangent of theta, which makes it tangent squared of theta, which is what the left side is. I think I forgot to put a problem on here that I intended to. Bummer. Oh well, that concludes that second assignment.